Good day once again, great souls, and welcome back to the Anti-Science Theory. So today I wanted to go through a continuation from the previous video on organic chemistry. If any of you have not seen that video, um, please make sure to check that video out before you come here because it basically just introduces a few fundamental things that you must know for this video and for more videos to come on organic chemistry. Um, So please make sure to watch that video. It's found in one of the playlists for organic chemistry grade 12. But nonetheless, as you all know the business, just don't forget to like, comment, share. Um, and your comments are very important to me, if I'm being honest, because it literally informs me as to what exactly it is that you guys need and whether or not the content itself is actually helping you, which I hope it is in some way. But nonetheless, please also share with your friends, share with your cousins and your aunts and your brothers and sisters. And don't gatekeep success, guys. Please, it's very important. Just make sure that you hit that like button, hit that subscribe button. Make sure that you share with your loved ones, guys. But nonetheless, let's talking more chemistry. So, under organic chemistry, I just want us to look at a couple of things before we start with something new. So in the previous video, we looked at the introduction to chemistry. There's a few fundamental things that we um, discussed in that video. So today, I just want us to look on onto what we call things like isomers, right? So I just want us to quickly start with that. Just want us to start with isomers. Okay. Now, what exactly do we mean when we say something is an isomer? When something is an isomer, we say that it's well, isomers in general are basically compounds with the same molecular formula, right? But obviously they would differ in the structural formula in different ways, exactly, right? So isomers are compounds with the same molecular formula but different structural formulae, right? And you have different types of isomers. This is very important for you to understand. Remember, I don't give precise definitions. I just summarize everything for the sake of comprehension, thorough comprehension to be exact. But in a nutshell, when you speak of isomers, we speak of compounds with the same molecular formula. If you don't know what I mean when I speak of molecular formula, please look at the previous video. But when you look at molecular formula, you should know what that is by now. But they have a different structural formula. We mentioned that in the previous video. What is the difference between a structural formula and what is the difference between a molecular formula, right? So, for example, we have different types of formulae of isomers. Sorry, the first isomer is what you would call your chain isomer. Chain isomer. The second one would be your positional isomer. Positional isomer. And the last one, which is quite frankly one of the easiest to identify, would be your functional isomer. Okay, so these are your three isomers that you have. So from these isomers, what can I do about them? What's so important rather? What's so important about these? Well, what's important is that in every exam, you must be able to identify between certain compounds, which two compounds are chain isomers of each other, which two compounds are positional isomers, which compounds are functional isomers, right? So that's a very important thing to understand. So when you speak of chain isomers, for starters, when you speak of chain isomers, just as the word says, chain, right? So these are compounds with a with a let me just give you the not the precise, but the a simplified definition. So chain isomers are isomers with the same, compounds with the same molecular formula, but different carbon chain lengths, right? So the length in the carbon chain differs. Length of carbon chain differs. Now, a very important aspect that you must understand is that when you're looking at two compounds and you're trying to compare between these two compounds, is compound A, B, and C. I need to find from those three. I need to see which two of those three are chain isomers. How do you identify that? So with the chain isomer, it is very important, very, very important, guys, to make sure that when you're looking at isomers, especially chain isomers, try to identify your substituents. Make sure that if one compound is has a certain carbon chain, then the other one must also have a certain carbon chain, but it must include substituents. But also keep in the fact that at the end of the day, they must have the same molecular formula. That is a very important part. The molecular formula must be the same. Okay? So when you're comparing two compounds, compare compounds with the same molecular formula. So what do I mean? Immediately, if compounds have different molecular formulae, disregard the fact that there would be any isomer at all. Literally, if I have a compound with a molecular formula of age age 4 and another one with C2H trying to think of an example, C2H2, automatically these have different formulae, right? You guys can see that these formulas are different. These molecular formulas are different. So automatically, once these are already different, you can't, they can never be an isomer at all. They can't be a functional, they can't be a chain, and they can't be a positional. Why? Because every isomer must have the same general formula. Sorry, must have the same molecular formula, regardless of whether it's a chain, a positional, or a functional. So isomers must have the same general formula. That's the first rule about it. They must have the same general formula, right? And another thing that you must look out for is the substituents. You must, when you're looking at chain isomers, you must be able to identify your substituents. That is very important. What did we say substituents are in the first video? We said substituents are also called your branches, the things that come on the side of the longest chain, right? So these are the things that you must look out for. So a couple of examples would be say some examples. So let's say I have a compound here, one, two, three, four, and I have a couple of things here, right? And then I have another compound here, one, two, three. Then I bring in another thing here, like that. By the way, ladies and gentlemen, I already told you guys that I'm not going to include hydrogens, right? Just know that where there's empty spaces, with where there are no elements connected to the bonds, just know that there are hydrogens there, right? Please don't forget that. Okay, right. So what do you notice between these compounds? Check something. Compound A has how many carbons in the, remember when we look at chain isomers, we look at compounds with the what? Same molecular formula, but they have the chain lengths that differ. So if you're looking at these two compounds, notice how compound, let's say that's compound A and that's compound B. So compound A has how many carbons in the longest carbon chain? It has four carbons. Four carbons in the longest chain. Okay, let me just write that properly. So the longest chain has four carbons. And then how many carbons are in the longest chain here? On compound B, the longest chain has only three carbons. Three carbons, right? So there's only three carbons. So what does that basically mean? Notice that 3 and 4 are obviously different numbers. So that tells you that these have different carbon chain lengths. Can I say these are chain isomers? Well, let's check. Remember, there are two things that must, two conditions that must be made for us to conclude that it's an isomer. It's a chain isomer. For starters, they must have the general formula, the same molecular formula. Is the molecular formula the same? Let's see. So on this one, the molecular formula is C4 since there are four carbons. And how many hydrogens do I have? I have one, two, three, four, five, six, seven, eight, nine, and 10. So I have C4H10. And then on this compound, how many carbons do I have? I have C1, 2, 3, 4, right? H. Remember, when you're looking at carbons, you're not looking at the carbons in the longest chain only. You're looking at all the carbons when you're trying to determine the molecular formula, right? So this becomes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's also 10 hydrogens. So notice something. Are the molecular formulae the same? Yes, definitely the same molecular formulae. Right. So the first condition has been met. Cool. I have met the condition of these things having the same molecular formula. But now the question is, do these compounds differ by substituents? Meaning, does one have more substituents than the other? Well, yes. Notice something. If this is my longest carbon chain, then this would be my substituent, right? My side branch. Notice how this is the longest carbon chain, and it doesn't have any side branches. It doesn't have any substituents. Therefore, yes, they do differ by side branches. They do differ by substituents. And from the first video, what did we say this type of substituent is called? It's an alkyl group. What is it called? Aha, it's called the methyl group. That's very important to remember. Right. So these are all the things that you must remember, guys. Make sure that before you conclude that two compounds are chain isomers, they must meet the required conditions. That is, they must have the same molecular formula and they must differ by substituents. Okay. And then we then look at the next one, which would be your positional I. Okay, let's just do a final example on this one. Let's say I have another one here. So I have a compound here, right? This is another compound that I'm given. This is a compound here. And by the way, just because I keep using methyl groups as branches doesn't mean you'll always have a methyl group. Please don't always think it's going to be like that in the exam. Okay, right. C. Okay. Let's see this one. Okay, right. So let me just add the hydrogens. I'm only going to add the hydrogens to the side branches, guys. Please do not forget that. Okay, right. Then there are bonds here. Bondio, 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 bondio. Bondio, 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 bondio. And bondio, bondio, bondio. Okay, so now let's look at these compounds. Once again, I have compound. Let's say this is compound X and this is compound Y. What is the first thing that you must check when you're comparing chain isomers? You must check the molecular formula. Let's see, is it the same? So I have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So that's C8. And how many hydrogens do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Did I count correctly there? Let's see. Okay, let's count once again. Let's count. So that's one that would go there. That's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes, okay, so I made a mistake there. That's actually 18. It did actually make sense why I picked up that mistake. But we'll see why that is in the later stage. Okay, right. So this is what we have. So we have C8 age 18. Okay, let's look at what we have on the right hand side. So how many carbons? I have 1, 2, 3, 4, 5, 6, 7, 8. So here I have 8 carbons as well, and I'm assuming I have 18 carbons, but let's be sure. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Yes. So notice how they also have the same molecular formula. So they already meet the first condition, right? But what's the second condition? Do they differ by substituents? Notice something. Both of these have substituents, right? Notice how this is a substituent. This is also a substituent. This is a substituent. That's a substituent. This is also another substituent. Do they differ by substituents? Yes. So notice how the first carbon has substituents, but how many two? Sorry, oh my God, I just gave you the answer. But how many substituents? It has two, right? So the number of methyl branches is two. And the number of methyl branches here is three. So automatically, since they have the same molecular formula and they differ by substituents, these two would be these two would then be our chain isomers, right? So that's a very important thing to remember. Always check your conditions, guys. Don't forget these. Molecular formula must be the same. Substituents must differ by substituents, right? Okay. And then we move on to the next one, which would be your positional isomer. Positional. Well, just as the name says, these are compounds with the same molecular formula, but they differ in the positions of the functional group. They differ in the position of the functional group. So as we continue to uncover everything under organic chemistry, there will be a time where you see what we mean when we say something is a functional group. What is a functional group in detail? But I'm just going to give you just a quick bite of what it actually is, just so I can make you understand what we mean when we speak of positional isomers. So for example, I'm going to mention I'm going to make an example with your alcohols. So alcohols are a type of homologous series, and they have the functional group OH, right? The hydroxyl group. So that is the functional group of alcohols. So assume I have an alcohol here, for example, that's 1, 2, 3, and 4. And then I have an OH there, right? Then that's compound A. And then what compound B? I have 1, 2, 3, 4, and then I have an alcohol right there. Right. And then the rest is just your hydrogens, right? Remember, I do not put in the ages, but please, ladies and gentlemen, very important. In the exam or in a test or anything whatsoever that you have to write for marks, don't be like me. I'm the guy who just doesn't feel like putting in the hydrogens. But I want you to know that the hydrogens are there. But in the exam, please don't be like me. Make sure that you include your hydrogens when you're drawing your structural formula. You lose marks if you don't do that. Please don't give the marker a reason to deprive you of what you worked hard for. So never exclude your hydrogens. Make sure that your hydrogens are always there. Don't be like this guy sitting right behind you, just listening to the voice and it's telling you, oh, I'm not going to put in the hydrogens. Let me also not do that. No, please put in the hydrogens. Okay. So now, why do we say these are positional isomers? For starters, what is a positional isomer? Well, there are things that you must look out for. For starters, they must have the same molecular formula. That's very important. The molecular formula must be the same. So these are conditions you must look out for. What else? Also, you must have a different location of the what? Of the functional. I'm just going to say FG. Please know FG stands for functional group, right? Different location. The location of the functional group must be different. Meaning, if this one is found at this carbon in one compound, and then in the other compound, the functional group must be found on a different carbon, right? So I'm gonna start putting numbers to these carbons. So that's carbon number one, number two, number three, and number four. And then here it's carbon number one, number two, number three, and number four. So notice something. Carbon on compound A, my OH, the functional group, is on carbon number one. So the OH is on carbon one. Sorry, on carbon number two. And then the OH in compound B is on carbon four. So since these are on different carbons, can we say that they are from positional isomers? Not Not necessarily, not too fast. We just need to look at a few things before we can conclude. For starters, we need to see that they have the same molecular formula. Remember, that's the first condition. So let's see. Compound A has a molecular formula of C4. And how many hydrogens do we have? We have one, we have two, three, four, five, six, seven, eight, nine. So we have nine. Oh my gosh, nine hydrogens. Oh, plus this one here. So that makes it 10. So that's C4H10, right? And then again, very important. Since I have, is it actually 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, yes. Right. So we have 10 carbons, right? So there's 10 carbons. Sorry, four. What am I saying? Four carbons and 10 hydrogens, right? So let's look at what we have on the other side. I have one, two, three, four, five, six, seven, eight, nine, and then 10. Again, so I have four carbons and 10 hydrogens, right? So let's see. So do they have the same molecular formula? Yes. So since the molecular formulas are the same, they meet the first condition. But now, do they have a different location of the functional group? Let's see. Well, notice how on compound A, the functional group is on location number two, on carbon number two. And then on compound B, it's on carbon number four. So is four and two the same thing? No. So since they are located on different carbons and they meet both the conditions, then you can say that A and B are indeed positional isomers. Right. So that's a very important thing that you must remember. Okay. Right. I think now we can then move on to the last one, which would be our functional isomers. Functional isomers. Functional isomers. Right. So our functional isomers, these are compounds with the same molecular formula, but they must have a different functional group. So they differ in Fg. So Fg, guys, I'm just going to say Fg is functional group, right? So there are two conditions that you must also check here. Condition number one, very common. What do you think it is? Aha, they must have the same molecular formula. That is very important. Very important. Make sure to check these things before you conclude. Same molecular formula. And what else? What else is also important? They must have different functional groups. So they must have different functional groups. Okay? Right. So let's have two compounds here once again. Oh, and before I do that, please note, very important, we have two pairs of functional isomers. There aren't any other. So we have pair number one. So we have pair number one, okay? And pair number one consists of it consists of your carboxylic acids. Don't worry too much about what these are. Carboxylic acids and your esters. Okay? And the second pair would then be your ketones and your aldehydes. Right. So these pairs, ladies and gentlemen, please don't forget, these do not separate. You do not try to mix these things with some other things, right? So they go together as a unit. They do not separate, right? So if you have a carboxylic acid, the functional isomer of a carboxylic acid will always be an ester. It can never be anything different. Similarly, the functional isomer of an ester will always be a carboxylic acid. If you're looking at ketones, with a ketone and an aldehyde, with a ketone, the functional isomer of a ketone will forever be an aldehyde. It can never be anything different. So these two will always go hand in hand. They must never be changed whatsoever. Okay, so let's look at a couple of examples. So it's fairly easy in an exam when they ask you to identify functional isomers. Can you, because if for some reason they give you a carboxylic acid, then they say give us a functional isomer of this carboxylic acid. You must remember, oh my gosh, the functional isomer of a carboxylic acid is definitely an ester. But now I just need to find what, an ester. Now it becomes easy for me to know what I need to look out for. I need to now look out for an ester, regardless of which ester that will be. That will obviously depend on the carboxylic acid. But what's important is that I know that I need to look out for an ester. That's the nice part about it. All right. So let's take a couple of examples here. So let's say I have a compound one, two, three, four. Okay, with the hydrogens here. So that's compound A. And then compound B would be one, two, three, four. Just do this. Okay, right. So this is what we have. So I have these two compounds. By the way, you might not know this yet, but you will as time progresses. But this compound is a ketone, right? So I have a ketone here, and I have here an aldehyde. Okay. So let's see what we mean when we say ketones and aldehydes of functional isomers. Well, you can't really know if they are if you don't know their what? Their functional groups. Remember, you must know this. So I'm going to tell you just a quick secret that you will find out later. That with ketones, the functional group of a ketone is your carbonyl group. And with aldehydes, the functional group is your formyl group. Okay. Now, uh, well, I mean, you can obviously see from now that they have they have different functional groups, right? So the first condition is met. Sorry, the second condition is met. They do have different functional groups. One is a carbonyl and the other is a formyl. So functional groups already different. We are fine with that one. And then now we then look at the molecular formula, right? So the molecular formula for this one is C4. How many hydrogens? I have one, two, three, four, 5, 6, 7, 8. So that's C4H8. And with this one, I have 1, 2, 3, 4, 5, 6, 7, and 8. So that's also C4H8. Now notice something. They have the same general formula. They have different functional groups. Can you conclude that they're functional isomers? Yes. Then you can conclude that they are functional isomers. Guys, please don't forget, even though you see that one compound is a ketone and definitely the other one must be an aldehyde for them to be functional isomers. Yes, that's true, but you can't just conclude just because the other one is an aldehyde. You need to make sure to check these conditions. Check, do they have the same molecular formula? That is very important, guys, because immediately when the molecular formulas are different, you can't speak about isomers at all, let alone being a positional, a chain, or a functional. You can't speak about isomers if the molecular formula differs. Already, a difference in the molecular formula goes against the first rule of something to be called an isomer, right? The first rule of something for us to conclude that something is an isomer, let alone being the chain, positional, or functional, the first rule that must be met in order for us to say something is an isomer They must have the same molecular formula. Immediately, when the molecular formulae are different, then they can't be isomers, right? Cool. Another quick mnemonic that you can use to remember this is what I also use to remember from time to time, and that is your cake, right? I mean, no, everybody loves cake. Everybody hates Chris. Okay. All right, so cake is a nice acronym that can help you remember. So what you just need to remember is that with cake, you must form a V at the bottom, a capital V at the bottom, and then you must have an upside down small V at the top, something like this. So that tells you that carboxylic acids goes with esters, so the C stands for carboxylic acid, in case you're wondering. So the C is for carboxylic acid, and the D stands for esters. And then the A stands for aldehyde, and then the K stands for ketone. Okay, so this is a very important thing to remember. So it tells you that the carboxylic acids and esters are functional isomers of each other. Functional isomers. Functional isomers. And then with your aldehydes and ketones, those are also functional isomers. Right. So that's what we have, right? So that is everything that you need to know on your isomers. Please do not forget these things, guys. Make sure that you still remember how to that you before you even decide that something is a chain, a positional, or a functional isomer. First, check if it actually is an isomer in the first place. How do you check? They must have the same molecular formula. Please do not forget that. Okie dokie. So I really hope that everything has been clear thus far. If there are any questions, complaints, concerns, comments, please don't forget to plug that into the comment section and I will then tend to it as soon as I can. But now I just want us to look at a couple of important things out there. Um, this is where we speak about our okay, but I'm seeing as because of the time. I think it's best if I look at what I'm about to look at in the next video. So I'm gonna leave the video, today's video here. Then in the next video, we will look at the rest of the things that I want you guys to do with me. Okay, so for now, we're just gonna leave it at isomers. Probably quite a lengthy video considering that I just covered isomers, but it's okay, man. We'll look at these things in depth as time progresses. But for now, I will leave you guys to it and to just think about it. Think about what we've done in this video and try to decipher everything. It might be a lot, but try to put it all in one nutshell. And we will eventually get to the bottom of this and understand what goes on in depth. All right, but from me to you, I shall see you guys in the next video. Have a great one. Goodbye.